Hey guys, good afternoon, good morning, or kung ano oras pa sa inyo. So welcome to Crash Course 9 Chemical Kinetics, okay? The second part of our Crash Course videos posted for today. So we will discuss first chemical kinetics, specifically reaction rate law determination, theoretical models on chemical kinetics, catalysis, and reaction mechanism. So guys, lahat ng about rate ng reactions, kinetics and reactions, we will discuss here, okay? So hang on guys, and I hope you are G, okay? That's G. Now, what is chemical kinetics? So chemical kinetics is a branch of physical chemistry that deals with the study of rates of reactions and the mechanisms they will undergo. Now, when we say reaction rate or the rate of a chemical reaction, it is related to how fast the concentration of reactants A and B and products C and D change over time. So for example, here we have a hypothetical reaction where A and B are your reactants and C and D are your products. Okay? So this means guys that A and B, the reactants, they are being used up. Yung C and D, they are the products and they are being formed. And A, B, C, D, yung mga small A, B, C, D, they are the coefficients from the balanced chemical equation. So rate is equal to negative 1 over A dA over dt and is equal also to negative 1 over B dB over dt. So what does this mean? So the negative sign for A and B, okay, it shows that the amounts of capital A and capital B, they are increasing. They are decreasing. Again, the amounts of A and D, they are decreasing, meaning the reactants are being used up in the reaction. Okay? And here, the dA over dt and the dB over dt here, okay, shows how fast the concentration of A and the concentration of B changes with time. Now, here, rate is also equal to 1 over C dC over dt, and it is equal to 1 over D dd over dt. Now, the positive values for C and D mean that their concentrations are increasing, meaning the products are being formed throughout the reaction. Okay, again, guys, dC over dt, dd over dt shows how fast the concentration of C and D changes with time. Now, dividing the coefficients such as 1 over A, 1 over B, 1 over C, 1 over D, and so on and so forth, make sure that the rate is the same, no matter which substance you measure. Okay, so again, guys, the reaction rate, it tells us how fast the reaction is happening. And we can measure the reaction rate by looking at how fast the reactants disappear, so ito, and how fast the products are formed. Ito, okay? Now, the following are the factors which affect the reaction rate. So first is the concentration. So higher concentration means faster rate because there are more coefficients when you have a higher concentration. So for example, okay, kapag mas may marami kang concentration ng hydrochloric acid, that speeds up the reaction. Its reaction with magnesium ribbon. So this is a common lab experiment. Diba? Natayin naman ito ng high school or ng college. Diba? Very basic yan. Na example ng chemical kinetics and how concentration affects reaction rate. Next, temperature affects reaction rate. So the higher the temperature, the faster the reaction rate. Because when you have a higher temperature, again, particles, they move faster. Okay, so for example, guys, sugar, it dissolves faster in hot water than in cold water. Next, the greater the surface area, the faster the rate. Okay, so powdered calcium carbonate, for example, mas nagre-react siya with acid than a marble chip. Okay, again, guys, if you have a greater surface area, they have more sites available. Okay, and for reaction, and therefore it results in a faster reaction rate. And lastly, as catalyst speeds up the reaction without being used up. Okay, so for example, manganese dioxide speeds up the breakdown of hydrogen peroxide. So manganese dioxide here is the catalyst for the breakdown of hydrogen dioxide. Ayan. Very easy, right? Now, let's describe the rate law. So the rate law shows how the reaction rate depends on the concentration of the reactants. So the reaction order, so yan yung M and yung N. Okay, these are the exponents to which the concentration of the species is rated. Okay, now through the rate law, guys, we can determine the rate constant. Okay. So the rate law is this. Rate is equal to the rate constant K times A, concentration of A to the power of M. So M is the reaction order with respect to A times B. So this is the concentration of B to the power of N. And N is the reaction order with respect to B. So guys, kindly correct this in your manual, dapat P2, where M plus N is the overall reaction order. Okay, so again, kindly correct this on page P57. Now, what if guys you have an elementary reaction? So guys, kung elementary reaction tayo, tandaan nyo na lang na yung orders ay equal to the stoichiometric coefficient. So for example, guys, meron tayong elementary reaction, always remember that the reaction order is equal to the coefficient, where M is equal to A and is equal to B. Now, let's describe the rate constant. So, the rate constant of a reaction generally increases with temperature. Bakit? Since at higher temperatures, guys, diba, the molecules, they will move faster. That's why that leads to a more frequent and energetic collisions between the reactants and therefore a faster rate for your reaction. So, the relationship between the rate constant and the temperature is often described by the Arrhenius equation. So, here, guys, we have the Arrhenius equation. Ito yun. Okay? K is equal to A to the power, A e to the power of negative EA over RT, where A is your pre-exponential factor and EA is your activation energy and T is your temperature. Okay? And K, of course, is your rate constant. So, again, guys, as temperature increases, okay, the exponential factor A also increases as well as the rate constant. Okay? And as a result, the reaction proceeds faster. Yeah. So guys, other forms of the Arrhenius equation is as follows. So first equation we have here, ln k is equal to negative EA over R times 1 over T plus ln A. So guys, we use this first equation here in a setup when we have a set of data. So we have a set of x and y values where x is equal to 1 over T and y is ln k. Then the second equation here is a 2-point equation for your Arrhenius equation. So ln k2 over k1 is equal to negative EA over R times 1 over T2 minus 1 over T1. Okay, so guys, kindly again correct this on your manual. Ito ang correct equation for our Arrhenius equation based on Petrucci et al. 2017. So guys, again, please correct in your manual on page P57. Okay, so guys, kindly correct it. Thank you. So, what are examples of a fast reaction? For example, fast reaction is the addition of LPG. And tama naman, diba? Because when you ignite the LPG, syempre mataas ang temperature yan, napakainit yan. That's why that results in a fast reaction. Okay? Slow reaction naman, conversion of graphite into diamond. Okay? So guys, bakit nga ba at higher temperatures we have a larger K? That is because guys, diba, at higher temperatures, yung particles natin nag-move faster, right? And they collide more often and with more energy. So yung rate constant K nyo, it will get bigger. Meaning, if K is bigger, the reaction will speed up. Again, K is higher at higher temperatures. Okay? I hope it's clear, guys. Now, let's derive the Arrhenius equation using its lateral logarithm form. Okay, so how do we derive the lateral logarithm form of the Arrhenius equation? So first, let's start with the basic equation here. It is k is equal to a e to the power of negative e over rt. Next, we take the natural logarithm of both sides. So ln nyo lang both sides, guys, and we will get these equations. So ln k is equal to ln a plus ln e to the power of negative ea over rt. Tandaan nyo lang, guys, diba? Ln a times e. Oh, dapat guys, kung isa-separate yan, ln a plus ln e, diba? Based on our logarithmic properties. Okay, and we know, guys, that the ln of e is just itself, right? Itong exponent yan. So ln e to the power of negative ea over rt is just equal to ano, guys? Siyempre, equal lang yan to, itong value na to is just equal to negative EA over RT. Okay, tandaan yan. Therefore, the natural logarithm form of the Arrhenius equation is ln k is equal to negative EA over R times 1 over T plus ln E. Okay, I hope it's clear, guys. Again, that's how you derive it. Next, how do we derive the two-point form of the Arrhenius equation? So these are the steps. So first, let's start again with the Arrhenius equation. So this is the basic Arrhenius equation, and then let's write two equations. One for a certain temperature T1 and certain temperature T2. So we have K1 and K2. And then let's take the K1 over K2 ratio and we will get this, diba? So combine lang natin sila. K1 over K2 is equal to AE to the power of negative EA over RT1 over AE to the power of negative EA over RT2. Next, let's simplify the ratio, guys. Okay? So K1 over K2 is just equal to, so of course, we cancel the A. And then next, guys, combine natin yung negative EA over RT1 and negative EA over RT2. So guys, ito, di ba, nasa inverse siya. So we can just simply, what? Lagay lang natin siya sa numerator side. And ang numerator nito, if you have here E A over RT2, so ang equivalent nito, guys, is just E to the power of EA over RT2, di ba? Kasi nasa denominator siya, nasa reciprocal siya. Okay? That's why naging ganito yung equation. So, E to the power of negative EA over RT1 plus EA over RT2 is just equal to this. So, simplify it through this equation. E to the power of EA over R times 1 over T2 minus 1 over E1. Tama naman, di ba, guys? Based on simplifying this equation. Now, let's take the natural logarithm of both sides and multiply to negative 1. So, ln K1 over K2 is equal to EA over R times 1 over T2 minus 1 over T1. Now, guys, after you have took the logarithm of both sides, you will get this equation, right? Now, at times equal to negative 1, you will get this answer here. Ayan. Okay? So, this is the final equation for your 2.4 of Arrhenius equation. So, guys, ito ang correct ha. ln K2 over K1 is equal to negative EA over R times 1 over T2 minus 1 over T1. Okay? I hope that's clear, guys. This is how you do it. Okay? Yeah, let's proceed. Now, let's try to answer the sample problem, okay? It takes 3 minutes to cook a hard-boiled egg at 100 degrees Celsius in Manila and 4.5 minutes in Baguio, where water boils at 92 degrees Celsius. What is the activation energy for the coagulation of egg albumin protein? Oh, guys, given lang tayo dito ng time and temperature. Oh, yung time, guys, we can relate it to the rate constant, right? We know that if we have a higher rate constant, therefore faster reaction rate, then it would take a smaller time in order for the egg to cook, right? Di ba? Gets naman ba, guys? Siyempre, kung mabilis nangyayari yung pagluto, it will take a smaller amount of time, di ba? For it to cook, right? Therefore, inversely proportional ang rate constant sa time. So, we can just rewrite the Arrhenius equation as, diba, ito yung initial, guys, diba? ln K2 over K1 is equal to negative EA over R times 1 over T2 minus 1 over T1. We can just write it in this way. ln T1 over T2 is equal to negative EA over R times 1 over T2 minus 1 over T1. O, bakit, guys? Diba, you're, again, sabi ko nga, inversely proportional ang rate constant with time. Because, syempre, if you have a faster speed, syempre, it would take a smaller amount of time to do the cooking, right? So, let's try to solve. So, ang hinahanap natin dito ay activation energy. So, transpose lang natin ang equation, guys, and we will get this equation. EA activation energy is equal to negative ln T1 over T2 divided by 1 over T2 minus 1 over T1 times the universal gas constant. So, guys, ang T1 natin, of course, is the 3 minutes, diba? This is T1. Oops, spoiler yarn. This is T1. So, this is T2, diba? Based on the sequence of the problem. Tapos, ang T1, yung temperature 1 nyo is this one, 100 degrees Celsius. Ang temperature 2 nyo ay 92 degrees Celsius. Diba? Tama naman. So, let's just simply substitute. So, EA is equal to negative ln 3 minutes divided by 4.5 minutes divided by 1 over T2. So, your T2 again is the 92 degrees Celsius. That is 92 plus 273 equals to 365. Ito, minus 1 over T1. Again, your T1 is 100 degrees Celsius. 100 degrees Celsius plus 273 Kelvin, we get 373 Kelvin. So, times 8.314 joules per mole Kelvin. Oh, guys, this will cancel out. This will cancel out. Pati yung K, diba? So, solving, we will get, ano kaya, guys? 5.74 times 10 to the power 4 joules over mole. Diba? Ayan. I hope that's clear, guys. Again, this is the answer. In other words, this is 57,400 joules per mole. This is your activation energy. Again, guys, this is the correct equation. This is the correct rewritten equation. So, kindly, guys, completely correct yung nakasulat sa manual nyo sa page P57. Again, this is the correct solution. Kindly refer to this one. Also, guys, activation energy hindi siya pwedeng maging negative. Okay? That's why this is the correct answer. It is positive 5.74 times 10 to the power 4 joules per mole. Okay, guys? And guys, ito yung tamang equation based on the book, diba? Kasi ang dami kasing references, guys, na iba-iba yung sinasabi about Arrhenius equation. But based on the book and based on our derivation that we did kanina, diba? This is the correct Arrhenius equation. And then just simply relate it with time to get the activation energy. Okay? I hope it's clear, guys. Let's proceed. Ayan. Next example. Determine the activation energy in the pre-exponential factor given the following set of data. So, guys, this time you're given a set of data. So, we will use the Arrhenius equation, the natural logarithmic form, and then we will assign x values and y values. So, your x values ay yung temperature. So, dapat kunin nyo, guys, ang 1 over 300K, 1 over 350, 1 over 400, 1 over 50, 1 over 500, etc. Okay? And then, for the y values, make sure that yung mga k values naka-ln, ln k, ln, ganyan. Okay? And then, input this in your calculators. Okay? So, guys, tandaan nyo ba ito sa inyong math bridging part 2? Di ba? Very similar. O, di ba? Parang iulitin pala yung discussion na. So, once you have inputted these values on your calculator, you will get a value for your slope, right? M. That value for your slope, ito yun. Again, ito yung slope. So, whatever value you get for the slope, multiply it by negative 8.314 para makuha nyo lang ang value for the activation energy. Again, yung makukuha nyo na value for the slope, multiply it by negative 8.314. So, that will get the value for the activation energy. Okay? And then, of course, guys, to get the value of the pre-exponential factor A, so that is your y-intercept, diba? Si B. Y-intercept, ln A. Okay? So, to get the value of A, guys, just simply input this on your calculator. So, E to the power of the value of your y-intercept, kung ano man yan. Okay? And then, you'll get the value of A. So, dapat na makuha yung sagot ay ito. Activation energy is equal to 2.3 times 10 to the power 4 joules per mole. And the pre-exponential factor A is equal to 8.04 times 10 to the power of 10 liters per mole second. Okay? I hope that's clear, guys. Diba? Na-review na natin ito before. Sige, let's proceed. Now, guys, rate law determination involves experimentally establishing the relationship between the reaction rate and the concentrations of your reactants. So, paano ba natin ito ma-achieve? This is through the measurement of the reaction rate changes as the concentrations of reactants are varied, while we keep other conditions constant. So, one method on determining the rate law and the rate of reaction is through the method of initial rates. So, here, we will measure the rate of reaction at the beginning of the process where T is equal to 0 and where we know the concentration of our reactants. Okay? So, by varying the concentration of one reactant at a time while we keep the other concentrations or other reactants constant, the changes in the initial rate can be used to determine the reaction order. Okay? So, for a reactant that depends on only one reactant, okay? Diretso na guys. A forms products where the rate law is simply rate is equal to KAN. Okay, where N is a reaction order. Now guys, when you have multiple reactants, we use this general ratio, or rate 1 over rate 2 is equal to KA1M times P1N over KA2M P2N. Okay, so i-ratio lang natin basically guys yung rate 1, rate ng trial 1, rate ng trial 2, and ang respective rate laws nila. Again guys, this is the basic form of your rate law. Okay, dapat memorize na yan. So how do we exactly do that? Okay, so let's try this sample problem together. Find the rate law expression for the given data. So here guys, given the trial 1, trial 2, trial 3, with initial concentrations of A, B, and the initial rates. When we say initial rates, these are the rates at P is equals to 0. That's why it is called method of initial rates. So guys, let's do the method. So first, let's get the ratio of rate 2 and rate 1. When we get the ratio of rate 2 and rate 1, we get 2.6 times 10 to the power of negative 4 m over s divided by 6.5 times 10 to the negative 5 m over s. Tapos, ratio din natin ang respective rate loss ng bawat trial na yan. So for rate 2, A times the concentration of A, 0.20 to the power of m. Kasi hinahanap natin ang reaction order with respect to A times the concentration of B at trial 2, which is 0.10 molar, okay, to the power of n. So again, to the power of n because we are trying to find the reaction order with respect to concentration B. Divided by, so again, the rate law with respect to trial 1. So 0.10, 0.10. Now guys, notice that we can just cancel out here. See 0.10, see 0.10. Oh, 0.10 to the power n and 0.10 to the power n, we can just cancel out. Yun yung point ng ating method of initial rates. Kapag nag-ratio tayo guys, dapat meron tayong pwedeng i-cancel out. And in this case, pwede natin cancel out si 0.10 to the power of n. Okay, of course, we can just cancel out A, right? Now let's just simply solve for whatever is remaining, diba? So 2.6 times 10 to the power of negative 4 divided by 6.5 times 10 to the power of negative 5, we will get 4, diba? Sige, tayo nga. Tapos, tingnan nyo guys, 0.2 to the power of m divided by 0.1 to the power of m, that is equal to 2, diba? 2 to the power of m. So, rate 2 over rate 1 is equal to 4, which is equal to 2 to the power of m. Oh guys, we can simply just find the value for m, diba? O anong value ni m kaya guys, ang magiging result natin ay 4, o diba? Alam niyo na guys yan, diba? Na 2 squared is just equal to 4, diba? Therefore, the value of m, the reaction order with respect to A, is equal to 2, diba? Very easy. Again guys, kailangan lang na meron tayong maka-cancel out, okay? Oh, next, let's try getting the reaction order with respect to B dito. O guys, tingnan nyo lang ulit, anong pwede nyo i-cancel out, diba? Sa A. O, in this case, guys, tingnan nyo kay A. Diba? Same lang ang concentrations ni A at trial 1 and trial 3. So, pwede natin kunin ang ratios ni rate 3 and rate 1, diba? Kasi same lang ng concentrations si A kay trial 1 and trial 3. Okay? Again, guys, gusto natin hanapin ang reaction order with respect to B. Kaya dapat cancelable si A. Okay? So, let's try that, guys. Let's get the ratio of rate 3 over rate 1. That is equal to, so again, the rates with respect to trial 3 and trial 1. So 6.5 times 10 to the power of negative 5 divided by 6.5 times 10 to the power of negative 5. Diba? And that is equal to the respective rate law. So rate law 3, 0.10 to the power of m times 0.2 to the power of n. Okay? Next, rate 1, again, K times 0.1 to the power of m times 0.1 to the power of n. So guys, we can just simply again cancel out what? Siyempre ito, kasi same lang sila ng value, diba? 0.10 to the power of n. So ano yung natira? Si 0.2 to the power of n divided by 0.10 to the power of n. So guys, tingnan mo natin sa left side. 6.5 times 10 to the negative 5 divided by 6.5 times 10 to the negative 5. O 1, diba? We get 1 on the left side. And then sa right side naman, 0.2 divided by 0.1 n. That is just equal to 2 to the power of n, diba? Therefore, we get this relationship. 1 is equal to 2 to the power of n. O guys, ano kayang value ni n ang makakapag-0? Ay, ano, mali. Ano kaya dapat ang value ni n so that we will get a value of 1 on the left side? O guys, kung ayaw nyo mag-solve, kung ayaw nyo mag-isip, calculator nyo na lang, diba? Shift solve for 1 is equal to the power of x, diba? Madali lang. So guys, n is just equal to 0, diba? 2 to the power of 0, tandaan is just equal to 1, diba? Anything, any number to the power of 0 is just equal to 1. Therefore, the reaction order with respect to B is equal to 0. Ano masasabi natin guys? That the rate law is not dependent with the concentration of B. Therefore, the overall rate law expression is as follows. Rate is equal to Ka squared. Ayan. So, pwede rin guys na lagay nyo ang value ng rate natin. Sige nga, na-solve nyo ba ang value ng rate natin? Okay, so that is equal to 6.5 times 10 to the negative 5, right? So again, your rate is equal to 6.5 times 10 to the power of negative 5, which is equal to Ka squared. So this is your rate law. Okay? I hope it's clear, guys. Diba? Very easy. Ayan. Now, another way to determine the rate law is through the integrated rate laws. Okay? Where for an nth order reaction with only one reactant, the integrated rate laws are expressed in a general linearized form through this linearized form. So in general, guys, ito yung mukha ng integrated rate law. Okay? Take note, guys, that this is not applicable, again, not applicable for first order reactions. Okay? So 1 over A to the power of n minus 1 is equal to n minus 1 Kt plus 1 over A naught to the power of n minus 1. Tandaan nyo to, guys. Okay? Ayan. But of course, guys, we just have to remember the usual orders of the equations, which are zeroth, first, and second order equations. Okay. Now, table 41 shows the summary for the integrated law parameters. Okay. So notice you guys, yung mga equations ng reaction rates, they are equated and integrated. Okay. Where the concentration is measured as time progresses. Diba? Ito yun. The concentration is measured as time progresses. Okay. And each order, they will have a unique integrated form and graph. Okay. Take note lang, guys, among all of these. Okay. So first order reactions lang, may constant half-life. So later we'll see that. Okay. So let's look at them one by one. So for zeroth order, guys, this is independent of concentration. So the change in dA over dt is equal to K. Okay, where the integrated rate law is equal to A, the concentration of A is equal to negative Kt plus A naught. Common rate unit M over S, and then again M over S for zero order. And our X value is usually T, the time, the Y value is just the concentration, and the slope is negative K, and the intercept is A naught. So guys, maganda itong reference kapag kailangan yung mag-graph ng mga certain given data. Okay? Next for first order, guys. Diba na-discuss natin ito briefly when we got to radioactive decay, right? Kinetics of radioactive decay. So again, for first order reaction, it is dependent on the concentration of the reactant, where negative dA over dt is equal to Ka. Oh guys, again, ang meaning nito guys is just equal to the rate, diba? Ka. And the integrated rate law is ln A is equal to negative Kt plus ln A naught. The common rate constant unit for a first order reaction is 1 over S. Guys, dapat memorize na to yung mga common rate constant units. Okay? So the X value for first order reaction is T, the time. Y naman, ln A, very straightforward, right? And then negative K ang slope, ln A naught naman ang intercept. Lastly, for second order reactions, okay? So we have here the rate law is Ka squared, kaya nga second order, diba? So the integrated rate law is 1 over A is equal to Kt plus 1 over A naught. Very notable, guys, wala siyang negative sign, okay? And the common rate constant unit is 1 over M times S, again, 1 over M times S, so, okay? And then guys, and the X value is T, Y value is 1 over concentration, the slope is just K, not negative K, okay? And the intercept is 1 over A naught. Again, guys, very helpful ng table nito. Now, how can we exactly derive these equations based on the basic rate law? Okay, so paano ba natin ito ma-derive? Just in case makalimutan nyo. Okay, so for a zero order reaction, this is how we can derive the integrated rate law. So first, you have to write the rate law first. So that is rate is equal to the change in A as time progresses. O diba guys? Again, bakit negative? Kasi in a reaction, the reactant A is being used up. Kaya siya naka-negative side. Okay, baka makalimutan nyo lang. And that is equal to K because again, zero order reactions, they are independent of concentration. Next, we just simply rearrange the equation so that we have different sides for the concentration A and T. Okay, so dA on the left is equal to negative KdT. Again, nag-rearrange lang tayo. Next, you integrate both sides. So integrate both sides. Oh, ano nga ba ulit ang integral ni dA? That is just A, di ba? And ang integral ni negative K dt is negative KT plus C, di ba? Because the integral of negative T is just negative T, di ba? And negative K is just your constant. That's why this is the answer. Guys, very basic ito. So, now guys, hanapin natin si A naught. Now, your A naught here is the concentration at T is equal to 0. So, let's find it. So, paano natin hanapin yan? That is through the constant C. Okay? So, A naught is equal to negative K times 0 because we know that A naught is the concentration at T is equal to 0 plus C. Rearranging, we get that C is just equal to A naught. Again, C is just equal to A naught. Okay? Now, we can just simplify the integrated rate law for zero order reaction where A is equal to negative KT plus A naught. So, again, guys, si C, ginawa ko lang siyang A naught based on this proof here. Okay? This is how you derive a zero order reaction rate law. Okay? Next, for a first order reaction. So for a first order reaction, the rate law is this one. Rate is equal to the change of A over time. Again, guys, negative because reactant A is being used up and is equal to Ka. Again, for our first order reaction, it is dependent of the concentration A, of reactant A. Okay, again, we arrange. So dapat nasa same side ang mga A, nasa different side ang KT. So dA over A is equal to negative KdT. Now, let's integrate both sides. So nilabas ko lang guys, si 1 over A. Okay? And then, to integrate, we will get integral of 1 over A dA is equal to integral of negative KdT. Oh, we know guys that the integral of 1 over A is just ln A. Therefore, the answer for this integral is ln A is equal to negative KT plus C. Now guys, hanapin natin si A naught using the value of C. Again, hanapin natin si C. Okay? Through A naught. So we know that A naught again is the concentration at T is equal to 0. So substituting A naught, ln A naught is equal to negative K times T which is equal to 0 plus C. Therefore, C is just equal to ln naught. Tapos substitute lang natin to sa ating integrated rate law for first order reaction and we will get this equation. ln A is equal to negative KT plus ln A naught. Diba? Very easy lang guys. Again, itong C naging ln A naught based on this proof here. And then lastly, for the second order reaction, okay? Again, let's use the basic rate law for a second order rate reaction. So rate is equal to negative dA over dt is equal to Ka squared. So bakit A squared? Again, this is a second order reaction. Rearranging, we get dA over A squared is equal to negative KdT. Tapos integrate lang both sides. So nilabas ko na lang guys, si 1 over A squared. Okay? Solving, we get 1 over A is equal to KT plus C. Again, 1 over A is equal to KT plus C. Okay? Now, we have to get A naught again at T is equal to 0, where 1 over A naught, again, is equal to K times 0, T is equal to 0 plus C. Therefore, C is just equal to 1 over A naught. Solving, we get the integrated rate law for the second order reaction. So guys, sorry, dapat second order to. Again, second order ito. We get 1 over A is equal to KT plus 1 over A naught. Ganun mag-derive guys, okay? Tandaan, naka-positive ito. Okay? I hope it's clear, guys. Let's proceed to half-life. So half-life is the time it takes for half of a substance, such as a reactant, to be used up or decay. So guys, diba, we have talked about this already in our in-org nuclear chemistry. So alam ko, familiar na kayo sa half-life, diba? So half-life, it is dependent on the overall reaction order. So again, guys, here are the equations, half-life equations for zero, first and second order reaction. So for a zero order reaction, again, half-life, T1 half is equal to A naught over 2K. So it is dependent on the initial amount. Okay? For the first order reaction, okay, it is equal to ln2 over K. So again, this time we have a constant half-life, diba? For first order reaction, T1 half is equal to ln K. And for second order reaction, it is equal to 1 half over K A naught. Okay? So for a zero order reaction, half-life depends on the starting concentration A naught. For first order, half-life is constant. So it doesn't change with concentration. And for second order, half-life increases as the concentration of A naught decreases. Okay? So for a second order, half-life and concentration is inversely proportional. Therefore, sinasabi lang dito sa half-life of second order reaction that this reaction will slow down more as it proceeds. Okay? So bakit nga ba tayo guys nag-measure ng half-life? It is because it is used to measure how fast a reaction or a decay will happen. Ayun. Now let's try to answer some sample problems. So first, determine the rate law for the decomposition of reactant A. So guys, how do we determine the rate law? So if you're given a certain data with X and Y values T and concentration A, okay, we just simply have to plot the given data using the integrated rate laws. Tapos, i-determine natin ang R squared, the mga graphs ng bawat law na yan. Okay, o bakit natin i-determine yung R squared? And bakit kailangan guys na close to 1? So guys, si coefficient determination, R squared, okay, it can be determined in your calculator. So, di ba guys, sa regression table ninyo, ang values for the y-intercept slope, di ba? So, doon din guys, you can also find R. Now, when you get the value of R, isi-square nyo yan sa calculator nyo, and then you will get the value of your coefficient of determination. Now, the coefficient of determination determines or measures the goodness of fit of a model to a certain data. Again, it measures or it gives us information of how good a fit a certain model is or a certain equation is to a given data. So guys, titingnan natin kung good fit ang zeroth order integrated rate law, first order integrated rate law, second order integrated rate law, and so on and so forth sa ating given data. And malalaman lang natin yan if R squared is close to 1. Usually, dapat 0.9999. Guys, pag close to 1 or equal to 1 ang R squared nyo, meaning guys, perfect fit ang model na yan, ang equation na yan sa inyong given data. Okay? So guys, kung perfect fit man ang rate law na yan, ang equation na yan, then meaning it will define the rate law for the decomposition of reactant A using this given data. So try natin guys. So again, these are the integrated rate laws for zero orders, first order and second order. Tapos guys, unahin nyo muna sa zero order. Okay? Kasi wala lang tayo idea kung ano tayong order, diba? So plot nyo muna yung X and Y values in terms of the zeroth order integrated rate law. So again, this is your X, diba? So this is your Y. So plot nyo lang. Tapos hanapin nyo ang slope. Yung slope will give you the what? For in this case, for the zeroth order reaction, will give you the negative K. From here, makuha nyo sa rate constant, diba? Next, find the R. Again guys, nasa regression table lang din yan ang calculator nyo. Just click R and then square it. And then you'll get the value of your R squared. So for a zeroth order integrated rate law, the R squared guys, ang mahanap nyo ay equal to 0.77. Sobrang baba niyan, sobrang layo sa 1. Therefore, the equation for zeroth order integrated rate law is not a good fit to your data. Therefore, masasabi natin, hindi zeroth order ang inyong reaction. Okay? Next, try natin naman ang first order integrated rate law. So again, this is the equation. So this is your x, this is your y. So this time guys, kung mag-input tayo sa calculator ng x and y values, x is still the same, t0, 1, 5, etc. Pero yung a nyo dapat naka-ln na. So ln 0.3, ln 0.221, and so on and so forth. Okay? Tapos, tingin ulit sa regression data nyo, hanapin yung slope. Again, it will give you negative k for first order's integrated rate law. Diba? Ito yung slope nyo. And then your r squared, guys, hanapin nyo ulit. And then for the first order integrated rate law, you would get an r squared equal to 0.93. So guys, this is high. This is close to 1. However, it is still not a perfect fit sa given data nyo. Okay? 0.93, malayo pa yan sa 1. Okay? So, therefore, masasabi din natin, guys, na in this case, baka hindi first order ang reaction natin sa data na to, na nangyayari sa data ito. Okay? So now, try naman natin this time ang second order integrated rate law. So again, this is the integrated rate law equation. Again, guys, dapat memorize ang ating integrated rate laws. Okay? Or if not, marunong na kayo paano mag-derive, diba? Tinuruan ko na kayo. So, again, assign values for your x, input nyo ulit. Tapos, input nyo ulit ang values for your y. So again, guys, for a second order rate law, syempre, ang mga y values ay magiging 1 over 0.3, 1 over 0.221, and so on and so forth. Now, guys, just get the slope. The slope will give you the rate constant, right? Ito yun. And that is equal to 1.19. Now, you get the r squared for this equation, and you will get 0.999. Guys, this is very close to 1, right? 0.999. Ano masasabi natin? Yung equation for the second order rate integrated rate law is a perfect fit to our given data. Ano masasabi natin, guys? Yung decomposition ng reactant A given this data is a second order reaction. Diba? Kasi it perfectly fit the data, perfectly fits the equation for our second order integrated rate law. Okay? So we can now write the rate law expression for this data. Yeah. Rate is equal to 1.19 inverse molar inverse minutes. So guys, this value here is just your k, right? Your rate constant. Again, mahanap to sa slope. A squared times A squared. So again, you have here reaction order equal to 2 because your reaction is a second order reaction. Okay? And guys, pag nagsusulat tayo ng rate law, make sure to write the units. Okay? So, tandaan guys, palate ang mga units per order, di ba? For a second order reaction, we know that it is m per minute or 1 m second. Depende sa given. Okay? Sa given kasi natin guys, given tayo ng minute. Okay? Kaya siya lagi 1 over molar times minute. Okay? I hope that's clear guys. So, ganyan mag-solve, okay? O, try nyo naman to on your own. So, determine the rate law for the decomposition of reactant A this time, given this specific data here. Okay? Again, you do the same as what I did earlier. Okay? Sige nga, try nyo nga on your own guys. So, ang sagot dapat guys is this one. Rate is equal to 0.49911 m over minute A. So, ang data nito will give you therefore, guys, ang data nito shows a first order reaction. Ang reaction for this one is first order. Okay? So again, check nyo guys. Solve nyo ha. Again, this gives you the rate constant K. Then mahanap nyo to sa slope. Okay? Paano mo nalaman? First order. Oh guys, A lang yan, di ba? Meaning first order ang rate law niya. Your order, reaction order is equal to 1, di ba? Okay. Ayan, kaya na yan guys. Now, so guys, for a reaction to occur, okay, maraming theories on paano exactly nagkakaroon ng products in a reaction, paano nag-increase yung speed ng reaction. So, one of these theories is the collision theory. So, sinasabi lang ng collision theory, guys, that for a reaction to occur, there must be effective collisions. So, a collision is only considered effective if it follows the following criteria. So, first, there must be enough activation energy for the reaction to occur. Okay? So, what is activation energy, guys? Kasi kanina is activation energy. So, activation energy is the minimum energy we need in order for our reaction to happen. Okay? So, higher activation energy means that we have fewer successful collisions and therefore a slower reaction. Tandaan na, pag mataas ang higher activation energy, konti lang ang successful collisions and that will result in a slower reaction. Okay? Tandaan guys, minimum activation energy lang kailangan natin in order for a reaction to happen. Okay? So, here are reaction profiles that shows you the activation energy. Okay? So, here on the left, we have the endothermic reaction profile. Okay? So, in this reaction profile, okay, you have a reactant that absorbs energy from the surroundings, diba, endothermic. So, ano masasabi natin sa products? The products will have more energy than the reactants. Ito yun guys, diba? It has more energy. Okay? It has more energy than your reactants here. Okay? So, what can you see about the graph? It goes up overall, diba? Pataas siya. Okay? So, yung energy difference ng inyong products and yung reactants niya is the energy absorbed, diba? So, when the endothermic process occur, again, in photosynthesis, in ice melting, diba? So, ito yung reaction profiles nila. Okay? I hope that's clear, guys. And ito naman yung activation energy. Again, the activation energy is the minimum energy we need for the reaction to happen, diba? Ayan. Makita nyo, guys, before siya dumating dito sa gitna, kailangan meron kang amount of activation energy that will allow fewer successful collisions to occur. Okay? Now, guys, we have here exothermic reaction profile. So, here naman, guys, again, exothermic, you have a release of energy, such as heat or light. So, ano masasabi natin if you have energy release? The products, they have less energy than the reactants. So, tingnan nyo guys, ito yung products nyo, they have less energy than the reactants here. So, yung graph nyo, pababa. Okay? Pababa. So, ang energy difference ng inyong reactants and inyong products ay yung energy released in the exothermic process. Again guys, example of exothermic processes, burning fuel and neutralization. Okay? So, again, yung nasa gitna guys, this is your activation energy. Again, you need a sufficient activation energy for the reaction to occur. Okay? Again, higher activation energy means fewer successful collisions and a slower reaction. So, guys, pag lower activation energy, meaning more successful collisions and faster reactions. Okay? I hope that's clear, guys. Next, let's go to this other criteria. Okay, so the second criteria for effective collisions is that the reactant particles must collide with proper orientations. So particles dapat mag-collide sila in the right way, in the right orientation, para mag-form ng product. So for example, we'll have here favorable collisions where the particles, ito, yung dalawang yan, will hit themselves hard enough. Okay, and they are aligned correctly. Okay, ano nangyayari pag meron tayong favorable collisions? Guys, the reaction will proceed and the bonds will either break or form depending on the reaction. Okay, o kunwari guys, wala may ka-shake hands kayo. O, di ba? So syempre guys, dapat yung face ng hand ng isang tao, face ng hand mo, dapat magkaharap face to face, di ba? Or di kaya, mag-shake hands kayo. O di syempre guys, di ba, magkaharap kayo. Pag mag-shake hands kayo. Di ba? Yun yung favorable collision. Magkaharap kayo, nag-shake hands. Okay? Now, ano naman yung tinatawag natin unfavorable collisions? So, unfavorable collisions, they will usually occur if, example, again, wala kang enough energy, or the collisions are in a wrong angle or wrong orientation. For example, dito, you have unfavorable collisions here. Okay? Anong result ng unfavorable collisions? You have no reactions. O, example natin guys, kunwari, mag-shake hands kayo ng jowa nyo or friend nyo, tapos nakapalikod kayo. O, di ba? Parang parang ewan. It doesn't work that way, right? Parang ganun lang. Okay? So, guys, only favorable collisions will lead to product formation. Okay? Now, let's proceed to transition state theory. So, another theory here will explain the essence of a chemical reaction. So, the theory simply states that a simple collision between reactant molecules does not readily cause a reaction. Ibig sabihin na to, guys, hindi porket nag-collide ang reactant molecules mo, boom, product agad. Hindi ganun, guys. So, sabi dito, based on the transition state theory, upon collision, the reactant molecules, they will form a transition state or activated complex. Okay? So, ano yung activated complex na yan or transition state? So, the transition state, okay, it is a short-lived, high-energy structure. Okay? Ayan, ito siya. Okay? So, yan yung in between the reactants and in between the products. Okay? So, this state exists at the peak of the energy barrier, meaning sa peak ng activation energy mo. Di ba nandito yung activation energy? So, yung transition state, okay, dito lang siya, at the peak of your activation energy barrier. Okay? So, what does the transition state or activated complex represent? So, it represents the point where the old bonds in your reactants are partially broken and new bonds in your products are partially formed. Okay? So, guys, basically, the amount of energy needed to reach the activated complex or the transition state is simply your activation energy. Right? Now, once the transition state is reached, yung reaction nyo, pwede na siya mag-proceed to form products dito sa right. Okay? So, the higher the energy of this transition state, the slower the reaction tends to be. Tama naman, di ba, guys? Pag higher activation energy, meaning the slower the reaction. Okay? I hope it's clear, guys. Again, this is your transition state. Now, what is catalysis? So, a catalyst, it provides an alternative reaction pathway that has a lower activation energy barrier. Okay? So, what happens if you have a catalyst? It speeds up the reaction without changing the enthalpy of reaction. Okay? So, here, guys, ito yung normal reaction nyo, di ba? Yun sa taas. Activated complex lang ang magpo-form. Now, guys, if you add a catalyst, it will give you an alternative reaction pathway with a lower activation energy. Ito yun. Okay? So, if it will give you a lower activation energy barrier or a lower activation energy pathway, okay, what will happen to the reaction? It will be faster. Okay? Yun yung point ng ating catalyst. Again, it gives you an alternative reaction pathway with a lower activation energy. Okay? Now, guys, there are two types of catalysts. We have the homogeneous catalyst and the heterogeneous catalyst. So, when we say homogeneous catalyst, okay, in homogeneous catalysis, meron kang reactants and catalysts na nasa same phase. Okay, so for example, si sulfuric acid, catalyst siya in the liquid phase reaction between acetic acid and ethanol. O, diba? Kasi liquid naman si acetic acid and ethanol. So guys, to learn more about homogeneous catalysis, kindly watch this video.
Homogeneous catalysts are in the same phase as the reactants. For example, if reactant particles are dissolved in water, aqueous, a catalyst that is also dissolved in water and aqueous would be acting as a homogeneous catalyst. Equally, if the reactants were in gaseous state and the catalyst also in a gaseous state, the catalyst would again be an example of a homogeneous catalyst. Aqueous transition methyl ions are commonly used as homogeneous catalysts as they have variable oxidation states, allowing them to easily oxidize and reduce other aqueous ions. A classic example of homogeneous catalysis is the reaction between iodide and 5-sulfate ions. Both of these ions are negatively charged, meaning collisions between the two are unlikely as the negative charges of each repel, and this makes the reaction very slow. An Fe2+ catalyst can be added, however, that provides an alternative pathway for the reaction to occur, massively decreasing the activation energy required and increasing the rate of the reaction. Here, the Fe2+ ion catalyst must also be aqueous, like the iodide and 5-sulfate ions, making it a homogeneous catalyst, and this an example of homogeneous catalysis.
Okay, guys, that is your homogeneous catalysis. Now, ano naman ang heterogeneous catalysis? So here, guys, you have a reactant and catalysts that are in different phases. Okay, so for example, okay, sa hard chem nyo, you will discuss the hydrogenation of alkene. Now, when alkene undergoes hydrogenation, okay, tapos ginawa niya yan sa surface ng solid palladium catalyst, it will undergo much faster. Okay, okay, syempre, solid palladium nyo is solid, di ba? So, guys, to learn more about heterogeneous catalysis, kindly watch this video first.
Heterogeneous catalysts are in a different phase to the reactants. For example, if reactant particles are in gaseous state and the catalyst used is a solid, the catalyst would be a heterogeneous catalyst, as it is in a different phase to the reactants. The most common type of heterogeneous catalysis is for a solid-based catalyst with gaseous or aqueous-based reactants, and the process occurs in stages. The reactants diffuse onto the surface of the catalyst, and then the reactants are absorbed onto the catalyst itself. It is at this point that the reaction starts and an intermediate gets formed, before the reaction is completed and the products made. The products desorb from the surface of the catalyst, and other reactant particles will then diffuse onto the surface to repeat the same process. A common example of this is the contact process, where sulfur trioxide is formed from sulfur dioxide and oxygen, both gases. A solid vanadium oxide catalyst is used, and as the reactants are gases and the catalyst is solid, the process is described as heterogeneous catalysis.
Ayan, guys, ha. So later on, when we get to adsorption in our special topics, we will learn more about heterogeneous catalysis. Kasi usually nahanap natin to, nakikita natin sa ating adsorption processes. Okay? Now let's proceed to reaction mechanisms. Now, reaction mechanisms, they are step-by-step series of elementary reactions that describe an overall chemical reaction. And each elementary step will have its own rate law. So example, guys, we have here a reaction mechanism. Okay? And these are the following rate law expressions. So for the first rate law expression, this shows how fast A is disappearing as time t progresses. Again, this shows how fast A is disappearing. That's why we have a negative sign, right? And that is equal to K1A. So guys, ang nangyayari dito sa K1A ay meron tayong forward reaction where A turns to B or A reduces B minus K negative 1B. Ang nangyayari dito naman, B is turning back into A, the reverse reaction. Okay? Oh guys, bakit minus? Dito, sa left side natin, we have here the rate of the disappearance of A, diba? So positive, guys, ang A turning into B because here, in this case, you have the disappearance of A. para maging B siya. However, naging negative ang sign ng negative K, negative 1B because in this case, you have B here turning back into A, which is the reverse of the disappearance of A. Okay? That's why may negative sign dito. Again, guys, ang rate na to, this represents the disappearance of A. Next, guys, we have here the appearance of B, or the change of B as time progresses. And ito ang kanyang rate law. So, K1A, okay, so nangyari dito, K1A, A turns to B. So, ang nangyari, guys, as A turns to B, the amount of B is increasing. Minus K negative 1B. So, this time, for this expression, B, the concentration of B is decreasing because B is turning back into A. Okay? And then minus K2B. Okay? So, sinasabi lang dito, guys, the concentration of B will decrease if B turns into C. Okay? Kaya may minus K2B. Again, guys, for this equation here, you have the appearance of B, the change in how fast B is appearing or how fast B is forming. So, K1A, positive yan because here you have A turning into B. Tapos negative naman for B turning back into A. Tapos negative naman ang expression for B turning into C. Kasi ang rate na to expresses how B is forming or B is appearing. Then lastly, we have here dc over dt. This shows us how fast C is forming. And isa lang ang kanyang rate law. It depends only on how much B is turning into C. That's why the rate law is K2. Okay? Again, it shows how fast C is forming. Okay? Where it depends only on how much B is turning into C. Kaya ang rate law ay ito. Okay? So guys, if ever you get confused on how you express the rate laws of elementary reactions or reaction mechanisms, kindly refer to this basic example here. Okay? Maganda tong basis. Okay? Now, how do we determine the rate law for a reaction mechanism? Kasi guys, marami tayong mga complex reaction mechanisms. So, approximation methods, they are used to simplify the analysis of complex reaction mechanisms. Okay? It will make it easier to derive rate laws from reaction mechanisms. Okay? So, ang goal natin dito, guys, is to use approximation methods in order to ensure that the reaction mechanisms are consistent with the overall reaction stoichiometry and that the reaction mechanism corresponds with the experimental rate law. Okay? So, one common type of approximation method is the steady state approximation method. So, in this method, the intermediates from the reaction mechanism are identified first. Okay, hanapin natin yun. Ano natin mahanap, guys? Yung mga intermediates, they are formed and at the same time, they are used up in the reaction. So, sa overall reaction, hindi sila mag-appear. Again, throughout the reaction mechanism, makikita natin sila na form sila or na-use and then na-use up sila. However, in the overall reaction, they will disappear. Kung anong significance niya? The rates of formation and consumption of an intermediate they are equal. Okay? Again, because the intermediates are formed and consumed throughout the reaction mechanism. So, the relationship for that is, okay, the change in the intermediate as time progresses is equal to the rate of formation of the intermediate minus the rate of disappearance of the intermediate is equal to 0. Okay? So, useful ito for complex reactions wherein intermediates are difficult to determine. Okay? Applicable din siya where the first step is lower than the second. Okay? So, guys, very helpful ang steady state approximation method. And to know more how to use the steady state approximation method, okay, let's answer the sample problem together. So, show that the reaction mechanism is consistent with the rate of reaction KNO squared times O2. So, here, guys, we have basically an experimental rate law. Okay, tapos titingnan natin if consistent ang reaction mechanism sa experimental rate law. Okay? And this is the given reaction mechanism. Okay? So, for step 1, we have a fast reaction here. Step 2, a slow reaction here. And we have an overall reaction. So, anong sabi ko, guys? Hanapin muna natin ang intermediate, di ba? So, tingnan nyo ang inyong overall reaction equation. You have NO, O2, and the formation of NO2. Oh, guys, ano yung wala dito? Any guess? Okay, wala tayong nitrate, di ba? Wala tayong nitrate, nitrogen trioxide, right? Wala tayong NO3 sa ating overall equation. It is being formed and being used up in the reaction mechanism. Therefore, NO3 is your intermediate. Okay? So, first step after we identify the intermediate is to obtain the rate law from the slow step. So, guys, hanapin natin yung rate law from the slow step kasi siya yung slow step, diba? Imagine nyo, ang nangyayari siya in 3,000 seconds tapos yung fast step in 2 seconds. So, syempre, guys, rate determining step pa rin ang ating slowest step. Okay? So, obtain rate law from the slow step, that is rate of reaction is equal to K2 NO3 NO. O, tingnan nyo siya. Tingnan nyo step 2. K2 NO3 NO. Meaning, guys, to form the product NO2, okay, we have to use up NO3 NO. Of course, times the rate constant K2. So, bakit K2? So, this is K1. Okay? This is K1. And then this is K negative 1. And this is K2. And this is K3. Okay? Or this is K, capital K. Okay? Now, guys, ang problema natin sa ating rate law from the slow step is that we have an intermediate. Again, hindi yan pwede, guys, because the intermediate, they are consumed, they are formed, and then consumed in the reaction mechanism. So, kailangan natin tanggalin ang NO3 na ito. Okay? So, how do we do that? After determining the rate law from the slow step, we assume equilibrium from the fast step. Bakit equilibrium? Because, guys, this is a fast step, meaning the formation, so the using up of the NO and O2 is just equal to the formation of NO3, diba? Because it is a fast step. They are in equilibrium. So, K1 NO times O2 is equal to K negative 1 times NO3. Kita nyo ba, guys? Again, once again, this is your K1 and this is your K negative 1. Again, we assume equilibrium from the fast step, okay, because it's a fast reaction. Therefore, yung formation ng products mo, formation ng reactants mo are what? Almost occurring simultaneously because you have a fast step here, okay? So after you do that, you express the intermediate NO3 in terms of the reactants of the overall equation. So ang gagawin lang natin, guys, ayan. So using the equation here that we got from our second step, isolate lang natin si NO3, which is your intermediate, right? Intermediate here. Intermediate is equal to K1 over K negative 1 NO times O2. Okay? NO times O2. Okay? Kita nyo ba, guys, how I transpose NO3 and the other variables? Now that we have this expression here, okay, we simply substitute this NO3 expression sa rate law equation that we got from the slow step. So ayan. So again, substitute nyo lang to, expression na ito, dito. Okay? And then we will get this rate law. Rate of reaction is equal to K2, K1 over K negative 1 NO squared times O2, which is consistent with the experimental rate law. So assume natin, guys, that K2, K1 over K negative 1 is just equal to capital K. Okay? Ganon. Clear ba, guys? I hope it's clear. Okay? Now, we have another approximation method called the pre-equilibrium method. So the fast steps in a multi-step reaction are assumed to be in equilibrium before the rate determining step occurs. Okay? So it is also another technique that we use to simplify the rate law. Okay? So dapat guys, yung first step natin is fast and reversible, meaning they will reach equilibrium quickly. And the second step is slower, meaning it is the rate determining step. Okay, so how do we do this? Let's say guys, we have a first reaction that is fast, between A forms B, and ang slow step nyo ay B forms C. Okay? Since step 1 is fast, again, it reaches equilibrium. Therefore, your K, your rate constant, is B over A, products over reactants. Therefore, B is just equal to KA. Okay? And then we assume equilibrium. Kaya tayo naglagay ng products over reactants. So B is just equal to KA. Now we can write the rate law from the slow step. So to get the rate law from the slow step, we simply write this. Rate is equal to K2B. Diba? We are using up B as we form C. That's why this is the rate law. Now we can just simply substitute B in terms of A. So rate is equal to K2KA. Diba? So now we have a rate law in terms of reactant A. Okay? I hope it's clear, guys. Ayan. And then lastly, we have the rapid equilibrium method. So in this method, the slowest step, yung sa multi-step reaction, yung is your rate determining step. Okay? Meaning guys, kung siya yung rate determining step, siya yung magkocontrol ng overall reaction speed. Right? So yung mga faster steps kasi guys, often nasa equilibrium na sila. Kaya wala silang masyadong effect on the rate of the chemical reaction. Okay? Kaya in this method, we will the basis of the rate law is based on the reactants in the slow step. Okay? So in this case, guys, tingnan nyo. The slow step really takes time, right? Ang sobrang laki ng energy niya. Sobrang laki ng activation energy niya. Di ba? Ayan. Has a high activation energy, right? Compared to the fast steps. Okay? So again, this is your slow step. This is your fast step. Okay? Now, how do we determine the rate law using the rapid equilibrium method? Okay? So here we have a proposed reaction mechanism. Okay? So we have N2O5 forms NO2 plus O2. Now, si step 1 guys, siya ang slow step nyo. Then the steps 2 and 3 are fast. So imagine guys, very slow ang step 1. As in, 1 hour yan. Tapos yung step 2 nyo, 1 second. Does that take 2 seconds? Oh guys, 1 hour equals to 3,600 seconds, right? So, ang total lang ng time of ng reaction nyo ay 3,603 seconds, right? So, malamang sa malamang, yung slowest step nyo, siya ang mag-determine ng rate law. Therefore, the rate law for this reaction mechanism is this. Rate is equal to Kn2O5. Okay? Since step 1 is the slowest step. Okay? And tama naman, di ba? This is our overall reaction equation. Okay? So, this is the rate law using the rapid equilibrium method. Okay? Ayan, Christmas na agad. So guys, let's now answer these glowy cards. Let's go guys. Sige nga, answer nga kayo. The speed at which a chemical reaction occurs, which can be quantified by the change in concentration of reactants or products over time. Ano yan? Tama, reaction rate. Next, it is an equation that relates the reaction rate to the concentrations of all species involved in the reaction. Ano kaya yan? Tama, rate law. Next, the relationship between the rate constant and temperature is often described by this equation. Ano kaya? Anong equation guys? Any clue? Tama, Arrhenius equation. Next, it explains how only a fraction of actual collisions between molecules allow a reaction to proceed. Yes, that is the collision theory. And as these are a step-by-step series of elementary reactions to describe an overall chemical reaction. Yes, this is your reaction mechanisms. And yay, we are done with Crash Course 9. Great job, guys. So now you may now answer practice test 9 for 25 minutes. And then after, you may proceed in watching Crash Course 10, our final crash course for physical chemistry on our special topics. Okay? Guys, special yung topics na to. Bakit? Of course, lumalabas pa rin ang mga special topics na to sa board exam, guys. Okay? Nasa TOS na to. Okay? So, manood pa rin, okay? See you later, guys, and goodbye.